All right, so today we're going to talk about non-standard graphs. Yes. Yep.
How do you write the range?
Oh, I didn't go over the domain and range. Okay, sorry, I forgot that. All right, so let's go through the domain and range here. All right, so the domain, do you all agree we're starting at 2 and we're going to infinity? All right, and now the range. Well, this arrow shows we're going down forever, right? Since we're going down forever, we're at, it's going to be infinity, but then, negative infinity. That's going down, so we're doing negative infinity, and what's our highest point? Was it 2 or 3? 2? 1, 2, 3, 2. Yeah, I'm trying to see where it lined up. So it was the 2 and then 1, 2, 3, 4. 4 up here. I was seeing where it lined up. All right, so it was the 2, 4 point. So this is 4, and that's included. So you always do your smallest to your biggest. Smallest to biggest. That would be our range. Anybody want to see it in set notation? All right, so if we're in set notation, this is x such that 2 is less than or equal to x, which is less than positive infinity. And for this one, we're going to have y such that negative infinity is less than y, which is less than or equal to 4. All right, let's talk about our non-standard graphs. This is not your basic sketch your parent graph, then shift. Why? If it were your basic sketch your parent graph, then shift, it would have to be in the format of y equals a times the root of x minus h plus k. And this radicand is definitely not x minus h. This is a quadratic. So this is why it's called a non-standard graph. It's not just our shooting star that we're shifting. It's going to be a special case. In these scenarios where it's a special case, what you want to do is you want to start out by finding the domain. So when you have a special case, you want to start by finding the domain. All right, so you tell me, is the domain restricted here? And yes, no, why? Is the domain restricted? Only Philip? Really? Nobody else knows if the domain is restricted? Okay, Philip, tell me.
It is restricted.
It is. How did you know?
The x is under radical.
Good, because our variable is underneath the radical. And can we ever have a negative radicand when we're sketching here? No, because if it's negative, that means we're going to have to deal with imaginary numbers. So what does that tell us? That tells us that my radicand, this x squared plus 3x minus 4, must be greater than or equal to 0. Quadratic inequality. How do we solve a quadratic inequality? It's a special process we have to take. What do I always call it? Pages? We have to test the regions. So first we factor. So we have x plus 4, x minus 1, We get our reference numbers, which will be -4 and +1, and now we test our regions. So I'm going to test x is less than or equal to -4. We're going to test -4 is less than or equal to x, which is less than or equal to 1, and x is greater than or equal to 1. Because we're greater than, because this inequality is greater than, we need the product to be positive. If it were less than, we'd need the product to be negative. So I'm going to test a number that's less than -4. Let's go with -5. So -5 plus 4, that's a negative. -5 minus 1 is another negative. A negative times a negative is a positive. Did we want it to be positive? Yes. So the first column is our winner. If the first column's a winner, which other column is also a winner? The last one is also a winner. We still need to check the middle one to make sure that it doesn't work out. So to test between -4 and +1, I'm going to test 0. So 0 plus 4 is positive. 0 minus 1 is negative. A positive times a negative is a negative. Do we all agree the middle column is out? So we now know our domain. So our domain, if we're writing it in set notation, is going to be x such that x is less than or equal to -4, or x is greater than or equal to 1. If you were to write this in interval notation, it would be -infinity to -4 bracket. The union symbol, that union, I'd also allow you to write the word or. I'm good with either one of those. Then bracket 1 to infinity. All right, so we found our domain. I want us to find our intercepts. Remember, for the x-intercept, we let y equal 0. So we're going to have 0 is equal to the root of x squared plus 3x minus 4. We're going to solve, so I'll square both sides. 0 is equal to x squared plus 3x minus 4. We factor x plus 4, x minus 1, and we get x equals -4 and x equals +1. So we got our x-intercepts. I need to find my y-intercept. Remember, for the y-intercept, we're going to let x equal 0. So y equals the root of 0 plus 0 minus 4. Do we agree the root of -4 is imaginary? Since it's imaginary, what does that tell us? No y-intercept. All right, let's sketch. All right, so my x-intercepts were -4. And +1. And these are shooting stars. These are shooting stars, but the domain tells us which way they're going. Right? So based on my domain, I have x is less than or equal to -4. So I start at -4, and where's less than -4? To the left or to the right? To the left. So I'm going to have one shooting star going to the left. But then it says, or x is greater than +1. So I go to +1, and now I have to be greater than +1, which is going to the right. And that's how our graph looks. Now, there's no graph between -4 and +1. And isn't that suiting? Because that's not part of my domain. All right, we set the domain. Let's write out the range. What is the range on this now that we have our graph? that gap between the two graphs doesn't matter for the range. You go from your lowest point to your highest point. Philip.
Y such that y is greater than 0.
You got it. Y such that y is greater than or equal to 0. You got it. Or you could say 0 to infinity. Okay, you guys try this next one on your own. Is anybody still copying? Sorry, anybody still copying? Raise your hand. Okay, next one. So I want it all. I want the intercepts, I want the domain, I want the range, I want the graph, I want it all.
Minus 4 to be greater.
Are we ready? No? Really? Okay. Another minute?
Oh, 0. How do I write that? Yes.
Alex is like, I think he's been absent for the last night, so he's still taking stuff. No, Alex. 3 days, he's taking He's only been absent for 3 days. He's been absent for like 4 years. He's absent last night. Well, not in a row, but he's absent much days. I guess he apologized.
Yeah, is this Alex?
Well, Joey cried it for like 5 hours last week. What's that?
I'm just scared. I haven't used it in a while. Hey,
Why are you not?
All right, we ready? Okay, so here, how do I know this is a special case, like this is a non-standard, that this isn't just shifting? Kai? It's not what? It doesn't follow the format. Good. It's not your standard just parent graph that's shifting. So we know this is a non-standard graph. So when we have a non-standard graph, where do we start? By finding what first? The domain. So let's find the domain. Our domain is restricted here because we have the radicals. So we know the radicand must be greater than or equal to 0. So we factor. And our reference numbers are -4 and +4. Because we have a quadratic inequality, we need to test our regions. So we are x is less than or equal to -4. -4 is less than or equal to x, which is less than or equal to 4. And lastly, x is greater than or equal to 4. Which sections did you guys find were the winners? The first column and the last column, and the middle column did not work out. Does anybody need to see me test the regions? Good. You sure?
No, I did it.
Okay. So our domain is going to be x such that x is less than or equal to -4 or x is greater than or equal to 4. We now need to find our intercepts. For the x-intercept, you would get x is equal to -4 and +1. For the y-intercept, you would have no y-intercept. -4 and +4. Does anybody need to see how I found either intercept? Solution. We're good? All right, so now it comes to the graph. So we have an x-intercept at -4, we have an x-intercept at +4. Because our domain is saying x is less than or equal to -4, we're going to the left. Because our domain is also saying x is greater than or equal to +4, we're going to the right. Nothing in between. what is our range based on this graph? Michael? You got it. All right, one more type of thing I need to show you for today. Oh no, actually 2 more things I need to show you for today. Okay, y equals 9 minus x squared. Okay, we recognize this as a non-standard graph, so we start by finding the domain. So we're going to say 9 minus x squared must be greater than or equal to 0. We're going to get 3 plus x. 3 minus x is greater than or equal to 0. Our reference numbers will be -3 and +3, and we're going to test the region. All right, I'm going to start off by testing -4. So 3 plus -4 is a negative, and 3 minus -4, that double negative makes a positive, so that ends up becoming positive. A negative times a positive is a negative. Do we want our product to be positive or negative? Positive. So what does that mean? This column's out and the last column's out. Should we still check the middle? Yes. So I'll check 0. 3 plus 0 is positive. 3 minus 0 is positive. A positive times a positive is positive. So that is our domain. All right, let's find our intercepts. So we have 9 minus x squared equals 0. 3 plus x, 3 minus x. So we get x equals -3 and +3. Now our y-intercept. We have y is equal to the square root of 9 minus 0 squared. So y equals the root of 9. All right, so you get y equals plus or minus 3. I will tell you the negative will reject, and I'll tell you why in a minute or so. But just know the negative will reject. So we have one x-intercept at -3. We have another x-intercept at +3. And then you have a y-intercept at 3 or maybe -3. Well, let's think about this. We said this was going to be a shooting star, right? Because of the radical. Said it was going to be a shooting star because of the radical. Was there a negation here to say that we're flipping the shooting star at all? There was no negation here saying we're flipping the shooting star. Since there's no negation here, are we going to cross that x-axis? Are we going to be going down? No. For that reason, we know that negative is not included. That negative y is rejected. So now I have one shooting star starting at -3, and now based on our domain, I'm between -3 and +3. So am I going to the outside or am I going towards each other? We're going towards each other, but we're not going to pass each other. What does that mean? It looks something like this. Right? If you were to continue and like stretch it out like that, then we would be going out of the domain, right? Because these arrows would say, okay, well then we're passing -3 and +3. We can't have that. The domain is restricted right between these. So we stop at where they cross each other on the y-axis. And this is our graph. So we had our x-intercepts, we had our y-intercept, we had our domain. What we have not discussed was our range. Who can tell me the range? You got it, 0 to 3. Okay, one more type of problem we need to see. Yes, absolutely. Which makes perfect sense because y equals this. So this is like the y is dependent on what this whole thing is. All right, next one. This is not a V. How do I know this is not a V? I know this is not a V because when it's a V, we're only allowed to have an x to the first degree inside those absolute value lines. So what is this? This is actually a parabola that we take the absolute value of. So what do we need to do first? We need to first sketch the parabola, then we'll take the absolute value of it. So I'm going to say not a V. All right, so I'm going to sketch y equals x squared minus 1. Is this your standard shifting on a parent graph for this parabola? Absolutely. So we have our parabola. I'm going to shift that turning point 1 unit where? Right, left, up, down. What is it? Heard it. 1 unit down. We're going to shift this key point 1 unit down. All right, now we need our intercepts. So we have x squared minus 1 equals 0, and we will get x equals plus or minus 1. Do we already know the y-intercept? Yep, we already know the y-intercept. So this is what my parabola looks like before I take the absolute value of it. Okay, so now what we need is y is equal to the absolute value of this. What does that mean? Can I have a negative as an x? Is that okay? Can I have a negative as an x inside these absolute value lines? Absolutely. But what happens is after I simplify this all down and I take the absolute value of it, my outcome must be what? Positive. So what has to be positive? Just y. X can be negative, but y, which equals the absolute value, must be positive. So this whole part of my graph that goes under the x-axis, that's the problem, because that's my y area and that's where it's negative. So we need to take this whole part of my graph and make it positive. So how am I going to make this positive? I'm going to take this -1, make it +1, and then the graph is going to start up, come down, hit that -1, bounce up to the green 1, and then back down. So this whole part of the graph then gets erased. And that's what it looks like, sort of like a W. All right, I know we just have a few minutes left, but there's really just one more thing I need to show you. Let's say I gave you this exact problem again, but I put a negative in the front. All that's telling us to do is this negative means to reflect over the x-axis. That's all that's telling us to do. So you graph out your thing normal, and then you reflect it over the x-axis. So our graph looked like this. Right? Didn't we look like this W? But now I'm going to take that W and reflect it. When I take that W and reflect it, that W is going to look like what letter? An M. So it's going to look like this. And this is the solution here, what I just circled in yellow. All right, we are done for today. Yes, Danny?